All right, we'll go ahead and get started. And if others join during the presentation, then they can see the Q&A section. But welcome everyone to our Friday webinar. Um, this, this webinar is about student success in chemistry courses at UNC Charlotte. And our presenter, Susan Michael, will be discussing with you all about chemistry courses. So without further ado, take it away.
All righty. Good morning, everybody. As Jesse said, my name is Susan Michael. I am the advising coordinator in the chemistry department at UNC Charlotte, and I am involved with the introductory and general chemistry programs on our campus. I teach general chemistry 1 and 2 virtually every semester. I'm also in charge of the lab that goes with general chemistry 2 in particular. Thank you for attending this presentation. At the end of the presentation, I'll show you my contact information so that if you have any questions that we're not able to answer during our Q&A time, please feel free to send me an email. I'll be happy to respond. My topic today is student success in chemistry courses. The information that I'm presenting to you comes from my work with students over, I'm sorry to say, decades in chemistry. But the concepts that we talk about today will apply not only to your success in chemistry, but to any other class that you take in your lifetime. My talk is going to be divided into 4 segments. First, I'm going to describe a little bit of what you sign up for when you register for a chem course on our campus. Second, we'll spend some time talking about your time as a student. What's expected of you when you become a student at the college or university level. Third, we'll talk about learning what it takes to learn anything, chemistry in particular, but anything that you're trying to learn in a course type setting. And finally, we'll talk about how to maximize your study time. Now, student success is a topic that has so many facets. I could literally talk for hours on this subject, but I know that you don't want me to do that. Today, we're just going to scratch the surface and get some broad strokes of what student success actually means. So let's get into it. When you register for a chemistry course at UNC Charlotte, you are signing up for multiple scheduled times every week. The bulk of your meeting time goes into what we call a class meeting. In the old days, we used to refer to this as your lecture time. This is either 2 or 3 days a week, and it's scheduled time when you will be in class with your instructor, either in person or virtually, depending upon how your instructor has the course set up. In many cases, you will also be signing up for a problem session time. This is kind of an instructor preference. Some instructors prefer to devote specific time to problem-solving skills outside of class. If your class has a problem session time, then you're required to attend either in person or virtually. Not all classes have problem sessions. Some instructors choose to weave problem solving into their class meeting. So class meetings are a little bit longer in sections that do not have problem session. Another thing that you sign up for is your quiz or exam time. Your attendance is required for quizzes or exams, and you are only required to attend on the days that a quiz or exam is actually scheduled. When your instructor gives you the course syllabus, then those dates will be clearly delineated for you, so you know exactly what days you're having quizzes and exams and can plan for those things appropriately. Your regular attendance at all of these things with proper attitude and preparation are the first markers of student success. Now, on our campus, virtually every class that has a lab has the lab as a separate course. So if you're taking General Chemistry 1 and you're required to have lab with it, then you sign up for General Chemistry 1, but then the lab is a separate class. It's Chem 1251L. So getting into the second topic of time investment. In order to learn anything well, you have to be willing and able to invest time in it. This chart shows a rough comparison of class time and study time expectations for students at the high school, undergraduate, and then graduate levels. Class time is shown in yellow, and study time, personal study time, is shown in green. Now, most of you have come out of high school, and in high school, for the most part, you spent roughly 5 hours in class per week with your instructor if you were taking chemistry or any other class. And there was some expectation, hopefully, that you were going to study outside of class. That depended on your instructor, it depended on your school, but in most cases that was 1 to 2 hours per week outside of class. Now, as you move to being a college undergraduate, the amount of time that you spend in class is going to decrease slightly. If you're taking chemistry, you're going to be in class anywhere from 4 to 4.5 hours per week. But the amount of time that you're expected to spend in personal study increases to 9 to 12 hours per week. This personal study expectation at the college level goes up dramatically. And that expectation is the driver for the term full-time student. If you're a full-time student, then for all of your classes combined, you're going to be spending over 40 hours per week working on school. That would be the amount of time that you would spend at work if you were a full-time employee. Now, when I first went to college, this was really hard for me. My high school experience didn't involve much studying at all. Math and science, yeah, I had to study a little bit, but for most other classes, it was basically a matter of getting ready for a test or practicing a little bit. I didn't have to work very hard at high school. When I went to college and looked at my schedule, I thought to myself, oh my gosh, look at all this free time I have. Yay! I was away from home and free time was abundant. It took me a while to figure out that I was really going to have to study. And it took me even longer to figure out what I was going to do during my study time so that I could earn respectable grades in college. So right now, in transitioning from high school to college, we're asking you to make this huge leap in the amount of personal study time that you invest in your classes by roughly 5 to 6 times. For a 3-credit hour course, students should expect to spend anywhere from 9 to 12 hours of study time outside of class every week. Now, it takes a lot of time management to work through this. It takes a lot of self-discipline to do this, but everybody can start by just building a schedule. Take a look at when your classes meet. Make sure that you schedule in your other obligations. If you have to go to work, if you have to do things at home, schedule those things in as well. Everybody's got to eat, everybody's got to sleep, so you have to build those into your schedule, and you want to include some time for fun as well. But every day you want to try to find some time that you can set aside to study for every class. Now for chemistry courses in particular, that time has to be devoted every day because daily review is crucial to long-term learning. Try to stick to the schedule as best you can, but once your semester is underway, there are going to be things that you just don't want to do, things that you procrastinate. And for those things, I recommend that you consider something called the Pomodoro technique. If you tend to procrastinate, then the Pomodoro technique can be a very helpful thing to help you overcome whatever hurdle is in your way. You can check it out in Wikipedia. Basically, the Pomodoro technique involves setting a timer for 25 minutes and completely focusing yourself on a task for that 25-minute time span. Remove any distraction, turn off your cell phone, put your computer away unless you're using it for your task. Tell everybody that you're gone, can't talk to anybody. But at the end of that 25 minutes, once the timer goes off, then you need to reward yourself. A 3 to 5 minute break with something that you can look forward to at the end of the time. It could be a snack, it could be listening to a song, it could be a little bit of Facebook time, whatever, but something to look forward to after you have invested this 25-minute time span. And if you do this sequentially for 3 to 4 Pomodoros, so to speak, then after 3 or 4 of them, you reward yourself with an even longer break, maybe an hour, where you actually talk to somebody else or call your folks or whatever, something that you can look forward to. There's a lot more that I could say about time management, but I'd like to spend the rest of my time here talking about studying and learning. Now, all brains are different. What takes you a short period of time to learn may take somebody else substantially longer to learn. And if you've been paying attention to your classmates, I'm sure that you already realize this. Figuring out how much time it takes for you to learn is important. So let's turn our attention to what it means to actually learn. When educators think about learning, we sometimes show the different levels of learning using Bloom's taxonomy. And this image, which comes from the University of Arkansas, pretty clearly indicates the different levels of learning that we think about. At the lower levels, at the bottom of this stack, we find remembering and understanding. These are levels that deal mostly with factual information, vocabulary words, definitions, and for better or worse, these are the levels of learning that are generally focused on in high school science courses. Now make no mistake, if you want to learn something to a higher level, you have to remember and understand things. At the college level, we generally ask students to learn at a higher level. In most science courses, we ask students to apply or analyze or evaluate scientific information, not just understand and remember it. Let me just give you an example. In one of my classes, we talk about the term electrolyte. That's a word that shows up in commercials and stuff like that. We spend a little bit of time defining the term, but when we focus our class time, we have to focus our class time at understanding electrolytes at these levels. In my entire professional career, I have never once asked a student to define an electrolyte on a test. I assume that when the word electrolyte shows up, students know what electrolytes are and have that foundation so that they can analyze electrolytes or evaluate the function of these things. So the question becomes, if you're learning something new, like electrolytes, how do you lay a strong foundation so that you can march up these steps to higher levels of learning? How do you march up this staircase toward success in college level science courses? So I'm going to ask you to think about something for a minute. What was the last thing, and it could be a concept or a skill or maybe a song, that you really learned, that you learned so well that you felt like it was part of you? Take a minute to think about that. All right. Now, think about how you learned that concept or skill. What did you have to do to really learn something? All right, for everybody, the answer to this first question is very personal. I'm sure we could go around and have you reveal what the last thing you really learned was, but in this setting, that's just not realistic. However, this answer to the second question for most people is kind of the same. How do human beings learn things very well? Most of us learn by practicing. So let's just take an example. Let's say that the last thing that you really learned was how to drive. Hopefully, you understand how to drive, can evaluate situations, and take your mad driving skills to a different area of the country and be a successful driver. You can combine your parts to make a new whole. Now, did you just learn by going to driver's ed, or maybe reading about the signs, or reading the manual from the DMV? I don't think so. In order to drive, you actually had to practice. You had to get behind the wheel and move that car out into traffic. In North Carolina, you had to log your practice hours, take the driving test, and if you passed and the state said that you were good to drive, they would give you a little card that said you were good to drive legally. Now, the same thing is true of learning concepts in science. The best way to learn to a high level is to practice. Just reading doesn't get it done for learning scientific concepts. One thing that's inherent with practice is that you will make mistakes. We all make mistakes. When you learn to drive, maybe you pulled out in traffic in front of somebody and they blared their horn at you. Maybe you hit a tree. Maybe you were involved in a bad collision. I hope not. But all of these mistakes make you a better driver today. They shape how you think about driving so that you don't engage in unsafe or illegal behavior. And the same thing is true about learning. You're going to make mistakes. If you were very successful in high school, this is going to come as a shocker. It can be difficult to deal with your mistakes at the college level if you're unused to making them in high school, but mistakes will help you move forward. Sometimes your mistakes will be very personal. Only you will know that something was wrong. But in some instances, your mistakes will be evaluated and your instructor may provide some feedback or comments to you to help you understand why something was wrong so that you can learn it better. It's important not to take this feedback the wrong way. Instructors provide feedback to help you learn, not to put you down. No instructor wants to put a student down. We all want to build you up so that your learning can be as good as possible. What I hope you understand at this point is that your study time has to be a time of practice where it's safe to make mistakes so that you can learn to a high level. Your study time can't involve just reading the chemistry books. Science textbooks are real snoozers. You're going to end up like this guy on the left here. Your study time has to be filled with activities, things that you're doing, so that it is effective in helping you move up the ladder of learning. I get this question all the time. What should I do during my study time so that I can improve my grade? I usually recommend 4 things for students to do in any study session. If you were thinking about one of those Pomodoros, let's say that chemistry was something that you procrastinated, the 25-minute Pomodoro would be divided into 4 segments. They won't be equally timed. The first item is just a warm-up. As a warm-up, you can spend just a couple of minutes recalling concepts and facts from your previous class. You can also spend a little bit of time with the memorization that's going to go into any science class. Every science class has a little bit of information that you have to memorize. Make it kind of like a game. How many things can you write down that you remember in 2 minutes? Go. And see if you can improve how many things you recall on a daily basis. Where you spend the bulk of your time needs to be with solving problems to practice the concepts. Now, when you take chemistry courses, you will have access to literally hundreds of practice problems. You want to start by solving the easy problems and then moving your way up to the hard problems. You have to move up to the hard problems. You can't just stick with the easy stuff. The easy things are going to be shown in the textbook, in the chapter, already worked out, and see if you can work out those same problems without peeking at the solution. Once you've done those, then you can go to the back of the chapter where there are even more practice problems. And you want to, of course, make sure that you're doing some of the harder problems at the end of the chapter. Now, if you can explain the solution of a hard problem to someone else, you probably understand that problem at a very high level. In the fall of 2019, explaining things to other people may be a little bit difficult. We're going to have social distancing. It may be hard to get together with other people. But you don't have to explain it to somebody else. You can explain a solution to your pet lizard, your stuffed penguin. You can explain it to your reflection if you want to. But talking things out, vocalizing what you know, and in some cases what you don't know, is a valuable activity. For many people, things don't actually become real until they're spoken out loud. You have to be careful with answer keys. Answer keys are like sugared soft drinks. They're sweet, but they are not very good for you. The purpose of an answer key is to help you if you get stuck. An answer key is not something that you memorize. A key can provide a false sense of security. You can look at a key and say, yes, I know how to do that problem, but until you have actually tried to solve the problem yourself, you haven't really practiced solving the problem. Most chemistry courses at the freshman level involve homework exercises that you're required to do on a weekly basis. For many courses, those homework problems are going to be electronic, and you can use them as practice tests. The goal is not to get the correct answer with the least amount of effort. The goal is to understand each practice question so that when an exam rolls around, you can be successful on those exams and demonstrate your knowledge to a very high level. The last two items in any study session could take anywhere from 10 to 15 minutes. Chemistry is a sequential science. What we talk about on the first day of class comes up every week. And it's important to review your prior learning. You never know when one subject, maybe from week 2, is going to provide a jumping off point for something that we discuss in week 11. You can't just take a chemistry course and say, oh, I took the first exam, now I can forget all that material and move on to the second exam. It doesn't work like that. You'll need to spend a little bit of time preparing for the next class meeting. In our freshman level classes, we ask students to do a little bit of work outside of class to prepare. You might be asked to read an excerpt from the textbook, watch a video, take some notes on something. But this preparation will help your class time be much more effective at preparing you for the higher levels of learning. Preparing for the next class meeting is laying the groundwork for higher levels. You want to know a little bit about what's coming before you sit down in class. So that's the information that I have for you in this particular session. I hope that I've given you some concrete things that you can do during this huge amount of study time that you're now going to have as incoming freshmen. I do have some resources that I think are good for anybody who's starting off in any class. The 3 resources that I've pictured here are pretty good reads. The first 2 are very small books. You could get through these in a couple of days. The New Science of Learning is a book that talks a lot about learning and what we know about the brain. When it makes sense to learn, what kinds of things you need to do to maximize your learning on a physiological level. The second book by Sandra McGuire is also an excellent small workbook type thing. Sandra McGuire is a former chemistry professor. She kind of transitioned out of teaching chemistry to thinking about student success, and she has written a number of good works on student learning and student success. The third book here by Barbara Oakley is a combination of these 2. It's a much longer work, but Barbara Oakley has a wide range of experience in success, particularly in math and science courses. The subtitle here is How to Excel at Math and Science, Even If You Flunked Algebra. So I'm going to open it up to questions, and Jesse's going to help me out here. If you have questions that you don't want to ask in the chat or in the Q&A box, then feel free to contact me via email. So Jesse, got anything showing up?
No questions at this moment. I'll give them some time if they want
Give
to
them
ask.
some time to think.
A lot of information to process, but please feel free to ask any questions.
Yes, please do. I'm happy to answer them.
No questions at this moment. But you do have Susan's contact information. So if you would like to ask her any questions directly, please feel free to email her. Also, the Office of New Student and Family Services. We have several other webinars going on today and every Friday. So you can always go to our webpage to check out other webinars that we're holding. And yeah, everyone have a great Friday. And any last remarks, Susan?
Yeah, somebody asked a question about how much stoichiometry is involved in general chemistry. A lot. Stoichiometry is really one of those foundational concepts, and we spend a lot of time in general chemistry thinking about stoichiometry. Okay. Well, folks, thanks for attending. And if you, like I said, if you have any questions about chemistry at UNC Charlotte or chemistry in general, feel free to shoot me an email. I'm at your service.
All right.
All right. Thanks, Jesse, for your help today.
Thank you. Everyone have a great Friday.
Yeah.
Bye.
Bye-bye.